Okay, this is Algebra 2, Lesson 4.5. In this lesson, we're going to talk about a new function as well as a new transformation. The function we're going to talk about is the absolute value function. That looks like y equals x with two bars on either side of it. The absolute value is the distance from 0. So when we talk about how far is 5 from 0, 5 is 5 units from 0, so the absolute value of 5 is 5. But negative 5 is also 5 units from 0, so the absolute value of negative 5 is also 5. So when we talk about the graph of the absolute value, all of the positive values just kind of make a straight line because 1 is 1, 2 is 2, 3 is 3, 4 is 4. But when we talk about the negative values, all of the negative values turn positive. So the absolute value graph basically looks like a V. We can translate the absolute value graph just like we have been doing by subtracting our horizontal component to go to the right or adding to go to the left inside the function, and then we can add or subtract outside the function to translate the graph up and down. The new transformation we're going to talk about is dilations. So I have my standard absolute value graph. If I do the absolute value of 2x, that graph looks taller and skinnier. I like to think about it if you had that function printed on like a balloon, like those happy birthday balloons, and when you blow them up they get bigger and bigger and bigger. So if I had this printed on a balloon and I pulled that balloon vertically, that would look like a vertical dilation. The graph gets taller and skinnier. The next example, again, just has me regraph the original so that I have a comparison. And the absolute value of x over 3 would be a wider or shorter graph. And that's the same thing when I have my function printed on my balloon. If I were to pull it horizontally or sideways, it would get shorter and wider. The third example has both a multiplication and a division happening. So off of the original, it would be, it would actually look wider than the original, but not much wider. It wouldn't be as wide as that one, but it would be wider than the original. It's kind of hard on my bad drawings, but basically we have a vertical dilation happening and we have a horizontal dilation happening, but because the horizontal factor is larger, it looks like a horizontal dilation. So in general, to dilate a function, you use multiplication. You multiply the function by a value. If the value you choose to multiply by is greater than 1, that will be a vertical dilation. And if the multiply number is less than 1, that'll be a horizontal dilation. In terms of our mostly linear functions, so the linear function and the absolute value function, that value for a is basically like slope. So you can determine the rise over the run to see what that value is. And when it turns out being bigger than 1, it's going to make it taller. But when it turns out less than 1, it's going to make it a little bit wider. And so we can do this with all the functions. We can do this with the lines to make them kind of steeper or less steep. We can do it with the parabolas to make them taller and wider or skinnier. We'll do it primarily with the absolute value though. Okay, so the first example says write an equation for a vertical dilation of factor 2 and a horizontal translation of 3 units. So I have my absolute value function. A vertical dilation factor of 2 means I want to multiply the function by 2. And then I'm also going to translate it horizontally 3. That's 3 to the right. So I have a minus 3 inside the function. If I wanted that to be vertical, it would have been outside, or to the left, it would have been a plus inside. The same thing we did with each of the other functions. And then the last example here, describe how g of x is the absolute value of x over 4, relates to the parent function. F of x is the absolute value of x. So this right here is actually A is 1/4. When you divide by 4, it's the same as multiplying by a fourth. So this will be a horizontal dilation of factor 4. Okay, and that is it for the notes. Good luck on the exercises, and please let me know if you have any questions.